Okay, so the fundamental theorem of calculus is one of the biggest things we cover in calculus. It's part of the reason why it's called the fundamental theorem. Anything that's fundamental is like core, right? It's down to the core. Well, the core of calculus is two things: derivatives and integration, right? Derivatives we did last semester, integration we're doing right now, right? The majority of the first semester is spent with derivatives. The majority of the second semester will be integration. Okay. So it combines both of them. It combines both of them. That's why it's called the fundamental theorem, because those are the two things that we do. We spend about 85% of our time in this class doing either something with derivatives or something with integration or both. Okay. The other 15% we do things like limits and differential equations, but still, that kind of really the only thing that has nothing to do with derivatives is limits, and that's kind of the only thing we do that has nothing to do with derivatives or integration. Okay, so the fundamental theorem of calculus is a theorem that links the concepts of differentiating a function with the concept of integrating. Right, differentiating means finding the derivative, which is slope, that's tangent, right? The slope of the tangent line, with the concept of integrating, which is finding area under a curve, right? It is the most common method we use in this class to integrate. Um, to integrate, let me add something to that. When we integrate definite integrals, so definite integrals, okay? When we did U substitution last week, we were working with indefinite. I'll show you the difference. It's pretty easy. The difference is really easy. I'll come back to it 1 second. Like, let's look at one of the examples. Let's look at this example we didn't get to here. This is indefinite because there are no bounds. We don't know where we're going from. We don't know what number, where are we getting area under the curve. We don't know. If we don't know, it's called indefinite. Today, we're going to look at things like this. We know where we're going, right? So that's what's called definite. Definite means there's bounds. Indefinite means there's no bounds. Okay? With bounds. So that's what we're going to look at. That's what the fundamental theorem. The fundamental theorem only looks at definite integrals. Okay? There are two parts to the fundamental theorem. Today and tomorrow probably we'll cover part one. Part one, the evaluation part. Okay? The thing about the evaluation part is you've done the first part already. You've done this part already. You just haven't done the evaluation part. And the evaluation part is you've done that before. It's probably the easiest part of it. All right. So here we go. This is what the evaluation part says. If f is continuous over the interval a to b, and capital F of x is a derivative of f of x. Okay, so capital F, anytime you see capital F, it means it's the antiderivative of f. You know how f prime, how last semester, f prime meant the derivative, right? That's what we use for the derivative, right? Well, what do we use for the antiderivative? Capital F. Capital F. Okay, so if you see capital F, that means it's the antiderivative of the original, of f of x. Okay, then we use this. Okay, if this doesn't make sense in blue up here, I know it's not blue on your paper, but it's green, blue and green on mine. The green is an example. Okay, so this is the original problem here. The integral from 1 to 5 for 3x squared, right? So the first thing they did was find the antiderivative. The antiderivative would be 3x to the third divided by 3. So it's really just x to the third. Okay. That's where they got x to the third. That's where we've been stopping, right? Now we're going to evaluate it, right? Evaluate means plug in a number, get an answer. When you're evaluating things, you guys have been evaluating things probably since 7th grade, 6th grade maybe, where you plug in for x and get something, right? That's what we're doing today. So what are we plugging in? They plug in 5 in here. Then they plug in 1 in here. So here they get 125, and here they get 1. So when you subtract them, they get 124. So 124 is the area under the curve from 1 to 5 for 3x squared. Okay? So we're combining what we've done before with what's called evaluation. Okay? Plug in the top bound first, plug in the bottom bound second, subtract them, you're done. Okay? You might get negative numbers. That means the area is under the curve, right? In this case, it's positive. So that means area is above the curve, or area above the x-axis, I should say. Okay? That's what it says. So if you see capital F anywhere, that just means it's the antiderivative. Kind of like f prime is the derivative. So if you see f capital F prime, that's just the original. That's just another way of saying the original f. Okay? Okay, so let's start with example number 1. So we've done example number 1. The only difference is you didn't have any bounds here, right? You didn't have any bounds. That's the only new thing. Okay? You've done number 1 before. So let's look at it. So we have to go from 1 to 2 for negative 15x squared plus 6x. So again, we can do this problem using just the power rule. We don't need u substitution here. If you don't need u substitution, don't use it. Okay, we can use the plain power rule. And you can do even this. If you want to, you can split them up. 15x squared here plus 1 to 2 6x dx. You can do that if you want. Some people, it's easier to split them up and do it. Some, it's just easier to do them all together. Up to you. Okay? So first thing we got to do is find the antiderivative. So power rule says add 1 to the power, divide by the new power. So add 1 to the power. So negative 15x to the third, divide by the new power, which is 3. Plus 6x squared, divide by the new power. And then we put a line after it. We put 2, 1. That's where we're going to evaluate it from, 2 to 1. So let's simplify it first. Negative 15 divided by 3 is negative 5, x to the third, plus 3x squared. Okay? So this right here is the antiderivative. So now what we're going to do is the evaluation part. Plug in 2 to x, get an answer. Plug in 1 for x, get an answer. Subtract those two answers. Okay, so I'm going to plug in 2 first. So here I get negative 5, 2 cubed, plus 3, 2 squared, minus. Then I'm going to do the same thing, except I'm going to plug in 1. Okay. Simplify and solve. Evaluate and solve. So let's see here. 2 cubed is, what is that, 8. So I get negative 5 times 8 plus 2 squared is 4. Over here, negative or positive 1 cubed is 1. Positive 1 squared is 1. Negative 40 plus 12. Negative 5 plus 3. So negative 28 minus negative 2. Can't subtract a negative, so we change that to adding, and we get negative 26. Done. That's the area under the curve. Okay. So it's combining what we've done in the past with the evaluation part, which you guys have been doing forever. Okay. All right, let's take a look at the next example here. Okay, so first thing you should be thinking is, can we use regular power rule to find the antiderivative here? That's the first thing we need to do, find the antiderivative. Can we use the regular old power rule, like we did on number 1, to find the antiderivative? If we can, that's the way we're going to go. If we can't, we're going to use u substitution just like we did last week. So can we use the regular power rule? No, we can't. Yeah, we can't because it's got division, mainly because it's got division, right? If there was no division, I mean, you could move this guy up here, but then it would be 2x to the third plus 3 to the negative 3. And then you can't distribute that because of that negative 3, right? And it's got negative 3, so we really can't expand it. So this one gives us no other option. We're stuck with u substitution. We've done u substitution before. It's not like anything we haven't done, okay? So now our next option is, what do we use as u? What are we going to use as our u? Because once we decide that, everything kind of falls in place. What's our u going to be here? Yeah. Yep, that's what I would pick. So let's use 2x cubed plus 3 as our u. Okay, go from there. So du would be 6x squared dx. And then we're going to divide 6x squared. All right, let's plug everything in. Let's see what we get. So we get 1, negative 1. 4x squared is going to stay. So I'm going to separate this. I should have done this at the beginning, but I'm going to separate it. So 4x squared's there. And then I'm going to put u here. That's to the negative third power. And then du is 1 over 6x squared du. Okay, so the green stuff, I put in u, and I moved it to the top by saying it's x to the negative third power. Okay. So once you plug it back in, your next step is cancel things out. We don't want x's and u's. That's a problem if we have x's and u's. Well, luckily the x squareds will cancel out. Okay. So we're left with 1, -1, 4, 6, u to the -3 du. 4, 6 is just a multiplier. It's a coefficient. So I'm going to move that to the front. Okay, so now I have u to the -3 du. So what I'm going to do here is I'm going to multiply, or sorry, find the antiderivative. So 4, 6 is going to be in front times the antiderivative, which is u to the -2. And then I'm going to divide by -2. When I divide by -2, that's the same thing as multiplying by 1/2. -1/2, sorry. When I do that, this guy and this guy will cancel out. So, and then this guy and this guy will cancel out. Not cancel out, but simplify, I should say. So I get -1/3 u to the -2. I don't need a plus c because these are definite bounds. I know what they are. If it was indefinite, I would put plus c, but I don't need a plus c today or for this problem. So I'm going to put u back in. U was 2x cubed plus 3. That's where we stopped last week. Now we got to do the evaluation part. We got to evaluate it from 1 to -1 now. Okay, so anywhere you see an x, plug in a 1 first. Anywhere you see an x, plug in a -1, subtract whatever answer you get. Okay. Let's see, so here, oh, wait, just put it right back there. Thank you. All right, so let's set this up. You get -1/3 times 2x to the third plus 3 to the -2. That's one of them. The other one's going to be exactly the same, except the number inside is going to be plugged in differently. Okay, so I'm going to plug in 1 for the first one and -1 for the second one. Okay, so start on the inside. So 1 cubed is 1 times 2 is 2, so that's 5. Over here, you're going to get 1 to the -1, or sorry, -1 to the third is -1 times 2 is -2. So that would be 1 to the -2. Okay. What is 5 to the -2 power? Or what is 1 to the -2 power? How do I do that if it's to the -2 power? How do I do that? There you go. You reciprocal. So it's not going to be 5. It's going to be 1/5 squared. So this guy right here is really asking, what is 1/5 squared, right? Because you put it over 1 and change that to a positive 2. So 1 over 25. So negative 1/3 times 1 over 25. Minus, same thing over here. You flip 1, you still get 1. So it's just going to be negative 1/3 times 1. Okay, multiply, you get negative 1 over 75 minus a negative, so it's going to be plus 1/3. Common denominator is going to be 75. So you get negative 1/75 plus 25 over 75, which is 24 over 75. Just under 1/3. Done. Okay. So before we go on to the next one, let's look at the majority of work was right here. That's where the majority of work was, right? What did we do here? Was there any calculus involved? No, really? I mean, be honest with you, a really good 8th grade student could do this, right? I'm not saying anything. I'm not comparing or anything, but I'm just saying this is not something. It's tedious, right? It's tedious. You have to be able to multiply. You're doing order of operations, right? So it's nothing that you guys can't handle. But this is where I see students make their mistakes right here. Not this. This is the calculus part, right? This is the calculus part right here, right? I don't see my mistakes necessarily right here. An 8th grade student had no shot doing this, has no shot doing this, right? You guys are the ones that need to do this, right? What I think sometimes is you guys focus on this part a lot. And then when you're like, oh, I got this part here, and then you drop a sign or something. Or when you plug in numbers, you plug in the wrong number or things like that. So it's not that you can't do it because you guys have been doing this in 7th and 8th grade, but it's just that it's overlooked sometimes. Okay. And someone looks at this like, man, that's hard. It really isn't, right? It really isn't. You're just simplifying, right? You're plugging in a number and seeing what you get. Okay. The hardest part, I would say, is the fractions here. And they weren't that bad because they were common denominators, right? That's kind of the hardest part there. It's tedious. Tedious just means it takes a little bit of time, but you can do it. You can handle it. Okay. Okay. So let's look at the next one here. Okay. So I'm going to give you about 7 minutes. I want you to do this one on your own. Okay. First thing should be find the antiderivative. That's the focus first. Once you find the antiderivative, then the next part's easy. Just plug in 2, positive 2, what do you get? Plug in negative 1, what do you get? Okay, so try this one. Okay, so I did the antiderivative part. I haven't done the evaluation part, but I did the antiderivative. So I rewrote it as 15 over 4 and then 5x plus 6 to the negative 1/4 power. Since it's a since it's a fourth root and it's underneath, it's on the denominator, it's a negative power. And then so 15 over 4, I just moved to the front because that's a coefficient. Found the antiderivative, plugged it back in. I got 5 times 5x plus 6 to the 3/4 power. Right? That's what we did last week. That's what we focused on last week. We were done there. We put a plus c in there. We were done there, right? So that part we've had practice with. And that's the hardest part. To me, that's the hardest part about this because after that, you're just plugging in numbers. Where did 1/5 at? 1/5, 1/5, 1/5, 1/5, 1/5. dx equals 1/5. Oh, I forgot to put in back to 1/5. So I should have put in the 1/5 here. So the 1/5 would go over here. Let me move, see if I can. So I still have a 1/5 here, so that would cancel out, and there would be no more coefficient. Makes the problem even easier. All right, so let me rewrite this. So I have 5x plus 6 to the 3/4, and now I have to evaluate it from here to here. Okay. Evaluate means just plug in. So let's plug in. 5x plus 6 to the 3/4 power minus 5x plus 6 to the 3/4 power. First number I'm going to plug in is 2. Second number I'm going to plug in is -1. Okay, so 5 times 2 is 10, plus 6 is 16. So 16 to the 3/4 power. 5 times -1 is -5, plus 6 is 1 to the 3/4 power. What does 3/4 power mean? When I say something is to the 3/4 power, like when I say something is to the second power, that means I multiply it times itself, squared, right? What does 3/4 power mean? Mm-hmm.
It's 16 to the power of 3.
That's the first thing, yeah. Take it to the power of 3, and then there you go, find the 4th root, right? So I get students all the time saying, which one should I do first? Should I cube it or should I find the 4th root? The answer is it doesn't matter. The answer is whichever is easier for you, okay? 4th root means what number times itself makes that number, right? Well, that's a lot easier. The 4th root of 16 is a lot easier than I think cubing 16. Cubing 16, I can't, this is a non-calculation, so I would have to do it by hand. But the 4th root, what is the 4th root of 16? 2. 2 times 2 times 2 times 2 makes 16. So 2 cubed, same thing with 1. 4th power of 1, the 4th root of 1 is 4. So you get 8 minus 1 equals 7. Okay. For these guys here, for the 3/4 power, and you'll get some crazy powers, they'll always be whole numbers. That's how you know you did your answer right. Okay. If Justin didn't pop in and tell me about this here, I would have known I would have gotten a wrong answer, because these numbers here wouldn't have created not so pretty numbers here, right? That's how you'll know. So let's say you doing this and you get something like 15. 15, there is a 4th root of 15, but it's a decimal, right? You'll know, because you'll be like, whoa, I can't do that. Without a calculator, I can't do that. That's a key sign to go back up here and be like, oh, okay, what did I do? Oh, I forgot to put this guy in here. You know, that'll be a key thing there. That's another way of figuring out if you did your answer wrong. Okay. Okay, so let's try this one here. Again, without the bounds, we have done this before. Without the bounds, we have done this before. Okay, that's what your homework assignment was on. We spent 3 days, 2.5 days going over stuff like this. So don't worry about the bounds right now. Do not worry about the bounds. Just worry about the antiderivative. Okay, so let me rewrite this first. So tangent is to the 1/2 power, because it's the square root of tangent, and then secant is squared. Okay. Pretty sure I'm going to have to use U substitution here because I have half powers, I have squareds. So my question is, which one is going to be U? Which one is going to be U? I have two options. I have tangent, I have secant. Which one is going to be U? Which one do you think will be U?
Tangent.
Why tangent?
The derivative is secant.
There you go. Yeah, the derivative's in there. If I pick tangent, first thing I'm going to have to do is find the derivative of tangent. It's secant squared. Well, lo and behold, it's right there. So it's going to cancel out nice and neat, right? I got to figure out a way to cancel. Once I pick a U, I have to figure out a way to cancel out the other X in there. Perfect. Sets it up perfect. So I would pick tangent of X as my U. Du is secant squared, right? If you're not sure, it's on your list, right? Dx. Divide by secant squared. Okay, so I get dx equals 1 over secant of x squared du. Okay, so now I'm going to plug in everything. So I know tangent is u. So when I plug in tangent, that's going to be u to the 1/2 power. Secant of x stays. And then I plug in my dx, which is 1 over secant of x squared du. Okay. Secant of x squareds cancel out, just like I wanted to. Okay. So all I have is u to the 1/2. U to the 1/2 is power. You can use the power rule for that. So you add 1 power, divide by that new power. I don't need a plus c here because it's got bounds. So instead of plus c, I put a line, and then I put my first bound on top, my second bound on the bottom. That's where we stopped last week. This week, we just have to plug it in. Okay, so let me move this down here a little bit. Actually, let me make a copy of this. Okay. Okay. Plug in back u. So let me put u back in. U was tangent of x. Oops, let me plug in u back in here too. Actually, that should stay u. U tangent of x to the 3/2 power. Okay. Again, that's where we stopped last week with U substitution. Now we got to plug it in. Okay, so 2/3. Actually, you know what? I'm going to run out of room very quickly, so let me do it down here. 2/3 times minus, so that guy, okay. What is tangent of pi over 4? 1? Alrighty. So here we get 2/3 times 1 to the 3/2. What is tangent of 0? 0, yep. Okay. Probably should keep these in brackets too. 1 to the 3/2 is just stays 1, because if you cube 1, you get 1. Take the square root of 1, you still get 1. Times 2/3 is just going to be plain old 2/3. Minus 0 to the 3/2 power is just 0. Times 2/3 is still 0. So this whole thing becomes 2/3. Okay. All right. Okay, so let me try to find, I'm going to skip that one for right now. No, let's do one more. I'm going to give you one more here. The last two I want to save for tomorrow because they're a little more, there's a couple little things in there that we haven't seen before, and I don't want to start that now, but I want to give you one more practice problem. So let me see, let me pick one. So find some space somewhere. All right, so let's try this one. Let's try. So we got from 1 to 4, 1 over x, and then root 16x squared minus 5. Nope, 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 don't do that one. Sorry, I looked at the wrong one. Oh, I'm on the wrong one. Okay. Okay, here we go. Zero, so okay, so 0 to 1. X times the square root of 1 minus x squared dx. Okay, do that. Okay, so u is 1 minus 2x, or x squared, sorry, 1 minus x squared. So derivative is negative 2x dx. Plug in dx, or sorry, dx equals negative 1 over 2x. So now I got to plug it in. So I get x u to the 1/2 times 1 over negative 2x du. Okay, the x's cancel out, which we wanted them to. So I get 0, 1, u to the 1/2 du. Okay, don't pack up yet, or your test is going to be a heck of a test. Because that tells me, Mr. Flores, this is too easy. Give me some harder stuff. Okay, we're not going to finish this, but we have 3 minutes, so let's use that time. Okay, so here I'm going to add 1 to the power, so I get u to the 3/2. Yep, I know. Got it. Thank you. And then I got 1 over 2, 1 over 0. Plug it back in. U is 1 minus x squared to the 3/2, and then I got it from 1 to 0. Okay, so when I plug in 1, you're going to get 0. Everything will be 0. When you plug in 0, you're going to get 1 to the 3/2 is 1 times negative 1/2 is negative 1/2. So you're going to have 0 minus negative 1/2, which is that'll be your answer. Okay. Mm-hmm. Oh, I forgot to divide. Yeah, I was going too fast. That's what I forgot. Thank you. Good. We'll finish it, since we only got a minute. We'll finish it on tomorrow, first thing. Okay. I'll finish it. I'll change it up right now. I'll fix it the way it's supposed to be, and we'll finish up tomorrow